Just going to do is we have a thrown angle of 30 degrees, like so. We have an angle of 30 for gravity. G is here. Now this one is G cos 30 and this is G sin 30. G sin 30 is G over 2. That's where we made the mistake. G cos 30 is root 3 over 2G. The thrown angle U goes up this way. It's 30 degrees. So it's 30 degrees here, which makes that U cos 30. U sin 30. U cos 30 being root 3 U over 2. U sin 30 being U over 2. Now, phi equals, phi x is going to be U, which is root 3 over 2U, minus G over 2x, or G over 2t. Yeah, alright. Phi y, anybody? U over 2 minus root 3 over 2 gt. Sx ends up to be root 3 over 2t minus gt squared over 4. And finally sy ends up to be ut over 2 minus root 3 over 2 gt, root 3 over 4 gt squared, excuse me. Okay guys, so once again the whole point of the question is to find out the landing angle, okay?
So here there's also U and S.
Huh?
So in SS if you got the U.
Oh, U, thank you. There we go. Root 3 over 2 ut minus gt squared over 4. Okay, so lads, what we're looking at here is, once again, we want to find out, just as the particle hits the ground, what is phi x and what is phi y. We once again have to find out that the time of flight is sy equals 0. That's when it hits the ground. So we're going to find the t value from that. So get your sy equation, which is going to be ut over 2 minus root 3 over 4 gt squared equals 0. Best way, quickest way to do this is to just rub out the 0, rub out that, and you're moving it across, so that's going to be an equals. Okay? Then you're going to cross off on the t's. Then you're going to bring up it, so it's going to be 4u over 2 root 3 g equals t. T therefore is, what's it going to be, 2u over root 3 g. Insert this value of the time of flight. So this here's the time of flight, how long it takes for it to hit the ground. What we're going to do next is we'll put that into phi x and phi y. So phi x is u over 2 minus root 3 over 2 g times 2u over root 3g. And phi x is going to equal what, guys?
That's phi y.
That is phi y, is it? That is awesome. Now, phi x, sorry, take it from the top equation, root 3 over 2 u minus g over 2 multiplied by t. T is 2u over root 3g. Now here we go, last, okay. The g's will cancel, the 2's will cancel, and what we're going to be left with is root 3 over 2 u minus u over root 3. Happy enough with that? Now just ignore the u, pretend the u's don't exist. There's a cheap way of doing this. Just put it into the calculator as root 3 over 2. Take away 1 over root 3. There's no point doing common denominators if this thing does it for you. Root 3 over 6. Is that right? Root 3 over 6 u. So phi x equals root 3 over 6 u. Next thing we're going to do is find phi y, guys. So phi y It's the same thing. So phi y is going to be u over 2 minus root 3 over 2 g times t, which is 2u over root 3g. This time root 3 will cancel with root 3, 2 will cancel with 2. We basically got a half minus 1. So phi y ends up to be minus a half u. Now, tan of our landing angle is basically minus phi y over phi x. That's going to be a half u, because minus minus makes a plus. And we're going to divide that by, what's a root 3 over root 3 u over 6. Okay? So in your calculator, the u's will cancel straight away. So all we have to do is just do a half divided by root 3 over 6. And I'm expecting 1 over root 3, or root 3 itself, root 3. So tan A equals root 3. Tan inverse that, A equals 60 degrees. Is that the landing angle we're looking for? There you go, landing angle there. Okay. Particles projected from the foot of an inclined plane which makes an angle A with the horizontal such that tan A equals 1 over root 2. The initial velocity is u at the same angle alpha to the plane. Prove that the particle lands at right angle to the plane. When you're talking about something landing at a right angle to the plane, if you zoom in on the plane, what happens is it lands at 90 degrees. So this here is 90 degrees. What does that mean about your phi x value? Your phi x value is 0. So lads, something that's pre-rehearsed and learned off. Anytime you see particle lands at right angles to the plane, phi x equals 0 is where you find your time. Okay? So always remember that. Now, what we have next is proof that it lands at right angles to the plane. So what we're going to do is we'll just work out I'm just going to work out what this angle is in the corner here. So alpha is 1 over root 2. That's going to make the hypotenuse root 3. That will make sine alpha root 2 over root, 1 over root 3. Just somebody double check these, just make sure I don't make an easy mistake that costs us a lot of time. So root 2 over root 3. I'm thinking I'm good, yeah? Okay, so you throw the particle up and then it comes down at, I know that's not symmetric there, but the idea is that it comes down at 90 degrees, okay? So we're going to work through our formulas. Going to construct my gravity triangle. Once again, parallel and perpendicular to the plane. Very easy to do. You have G here. And what angle is this going to be? Alpha. This is also thrown at alpha. So for our gravity triangle, we're going to have G cos alpha here. And we know that G cos alpha is root 2G over root 3. We're going to have G sine alpha over the other side, which is going to be root 2 divided by root 3G. Now, we have to throw our thrown angle. Huh? Oh, yes. 1 over root 3, is it? Believe it or not, that's where most of the mistakes come out. This actually, before you even start making the equation in this part here, is where most mistakes take place. So, 1 over root 3G, thank you. Now, what we've got to do next is our thrown angle. And what about the thrown angle? It gets thrown at alpha, it gets thrown at u. That makes this one 1 over root 3u going up this way here. And then going across, it's going to be root 2 over root 3u. Everybody happy with that? Okay, so what we're going to do next, just segment this here, and we're going to start working out our equations. So, phi x equals what, guys? Anybody? No, phi x? I'm going for root 2 over root 3u. That's your u value, because remember it's u plus at. Gravity's working, acceleration's working against you. So minus 1 over root 3 gt. Phi y, anybody? 1 over root 3 u. Take away root 2 over root 3 gt, because that's working against it, your motion. Now phi x and phi y are simple once you make them. Add on a t, half the second one, add on another t, and then sy equals 1 over root 3 ut minus, we'll keep it the same, root 2 over 2 root 3 gt squared. Okay guys, so that's our 4 formulas there. Just reduce them in size there, so just use them up there. Now, what's our information when we hit the ground? We have 2 pieces of information, don't we? Now, the whole point is I have to prove that it lands at a right angle. Do you understand that? So I have to prove that phi x equals 0. That's how you prove that it lands at a right angle. Phi x will be equal to 0. So what I have to go about doing first is using sy equals 0, find the time of flight, put the time of flight into phi x, prove it's 0, and then once I prove it's 0, then put into phi y, prove that phi y is just a number going downwards. Okay, so let's see what happens. Start off with sy equals 0, and once again it's going to be 1 over root 3 ut minus root 2 over 2 root 3 gt squared equals 0. Bring it over to your side. 1 over root 3 ut equals root 2 over 2 root 3 gt squared. Cancel out the t's. Okay. Now, cancel out the root 3's. Root 2 divided by 2. 1 over root 2. Bring up the root 2. Bring the u still there. Bring the g underneath. T equals root 2u over g. Okay. Now, what does the question say again? Prove that the particle lands at right angles to the plane. Okay, so what they're doing is I have to prove that's a right angle. Yes, I'm going to prove phi x equals 0. Now, phi x equals root 2 divided by root 3 u minus 1 over root 3 gt. So it's going to be g, and now we have the root 2 u over g times t. Now, you notice that the g's will cancel. There's no t there, I substitute in t. I'm going to get root 2 over root 3 u minus root 2 over root 3 u. That equals 0. Phi x equals 0 means what, guys? It means when you land at your plane, your particle is going straight into it, because it's not going this direction at all, because phi x is 0. Okay, and so it's enough to show that phi x equals 0. Okay, so that's, we have to get phi y dead. So part 2 of this is find the range up the plane. How do you find the range again? We know the range. You find the distance from here to here, an sx value. So you're going to find the sx at this time of flight here. Okay. So we're going to do next. Next part of the question. So Sx equals root 2 by root 3 ut minus 1 over, what is it, 2 root 3. Oh, got to substitute in t. Root 2u over g, then minus 1 over 2 root 3 g. Now what's t squared, guys? T squared? 2u squared over g squared. Thank you, Neil. And then let's see what happens. We're going to get 4u squared over root 3g. You're right, it's 2, isn't it? Yeah, thanks. Root 2 by root 2? 2. That it, is it? Yeah. Thanks. 2 cancels with 2. G squared cancels with that g there. And you get u minus u squared over root 3g, isn't it? So the answer is going to be u squared over root 3g. Now, the next one's an interesting one. Have you guys done energy in physics?
Yeah.
Like potential and kinetic?
Yeah.
Okay, for those of you who don't know, when an object has a distance above the ground, it has what's called potential energy because of gravity. So it takes effort to lift an object above the ground. So when you drop it, it has energy stored, okay? This energy stored is mgh. So for example, a 10 kilogram object at a height of, what are we going to say, the height of I don't know, 20 meters above the ground, that will have energy stored in the form of 10 multiplied by 9.8 for gravity multiplied by 20. What's that turn out to be? 98 multiplied by 20? 1960? Yeah, 1960 joules, okay? The next type of energy you can have is energy of a moving object. It's a half mv squared. This usually relates to linear motion going just directly to right or directly to left. Once again, if your object weighs 10, however, this time it's going, I don't know, let's say 15 meters per second in one direction. Your energy that comes from moving is basically a half 10 multiplied by 15 squared. What's that, anybody? Is it 37.5 or something like that? No, 375? Was it? A half?
I got 1,125.
Did you? That's fair enough, so 1,125. Never mind, I'm miles off. Now, if you had an aeroplane flying in the air, what two types of energy does it have? An aeroplane in the air going straight across. It has potential energy because it's well above the ground. It has gravity on its side if it ever wants to drop. And it also has kinetic going directly to the right. So it has its two forms of energy, okay? So that's a brief intro into just energy, okay? Now, what the next question says, and what it's specifically looking for is, show that the principle of conservation of energy. What does that mean? Energy at the start equals the energy at the end. Is that right? Energy at the start equals energy at the end. That the sum of the kinetic and potential energy of the particles is the same at the moment of takeoff and landing. So takeoff and landing, okay? So, this is going to be interesting. So they're the same at takeoff and landing. Now, at the beginning, you're located this much off your plane. Do you have any potential energy at that point? Because you're not off the ground, you have no potential energy. You only have kinetic energy. You get thrown at a speed u. You have a u the second you leave the ground. So you use a half mv squared for kinetic energy, but because your velocity is u, it's going to be a half mu squared. Everybody happy with that? Now, the energy at the point of landing is what, guys? At the point of landing? Sorry? Now, you have a height above the ground, don't you? Because it's a height above the ground. So you're going to have mgh, and it's going to be plus a half mv squared. mv squared being whatever velocity you hit the ground at. Is that right? Now, what we learned earlier is that the Vx equals 0, yeah? So we're going to have to find out what Vy is. So we're going to go back up to the top and we're going to look at Vy. And I'm just going to rub out the Vx equation because I don't need it. I know it's 0. So what I'm going to do is I'm going to find out what Vy is. So Vy at the time of flight is 1 over root 3 u minus root 2 over root 3 g multiplied by t, which is root 2u over g. Cancel, cancel. Minus 4, so I nearly did that again. 2 over root 3u. 1 over root 3u. So what's Vy, anybody? Minus 1 over root 3u. So it hits the ground at a velocity, what's it, u over root 3. Now I'm ignoring the sign. Why am I ignoring the sign? Is there a g there as well? No, there's not a g. So it hits the ground like that. Okay, are we happy with that? The g is cancelled, they cancelled, okay? So, next thing I have to figure out is what's my height. Anybody have any clue how I can find out what the height is? Remember, this is angle alpha. Anybody know? What did we find out a second ago? We have the range, don't we? And what's the range again? It's up there, isn't it? U squared over root 3g. What function will give us the height then? Sine alpha equals h over the range. Sine alpha equals h over u squared over root 3g. What is sine alpha again? We had it up the top. Sine alpha is 1 over root 3. Thank God for that. Now, what I'm going to do is I'm going to bring this fraction to the top. I'm going to turn it upside down, so that the u squared will end up on the bottom. The root 3g will end up on the top. Let's get rid of that there. Next thing I'm going to do is cross multiply. I'm going to get u squared over root 3 multiplied by root 3. 3g equals h. Happy enough with that? Now, what I have to prove next is that mgh is m times gravity times u squared over 3g plus a half m, and what did we say v was again? Vy was 1 over root 3 u. Have to square that out. Now, what we're going to get here is mgu squared over 3g plus, that's going to be 3, so that's going to make it a sixth. Where I lost a g somewhere. Where did I lose the g? Oh no, I didn't lose a g. Grand. Mu squared over 6. Now this g will cancel out with this g. What's a third plus a sixth? Third plus a sixth? A half. Last time I checked, it's 2 6 plus 1 6 is 3 6, which is a half. A half mu squared. This half mu squared is your total energy when you land. We said that our total energy when we start off is a half mu squared. Do they balance up? Yes, they do. Conservation of energy. Okay?